Welcome to SciSpectrum Lab Essentials, your source for equipment, instrument, and consumables.
All right, today we're unboxing something, well, a little different. It's not the latest gadget, but it's a piece of lab equipment that holds a really surprising power. So, what on earth does this mystery box do?
So check this out. It might just look like some beige box you'd find in any lab, but it has a kind of superpower. It can precisely measure color. It takes something our eyes see, the shade of a liquid, and turns it into cold, hard, objective data. The real question is, how?
Like any good mystery, the first clue is hiding in plain sight. It's right there in its name. Let's break this thing down.
Digital photocolorimeter. Whoa, that's a mouthful, right? It sounds super complex, I know. But if we just look at the root words, the whole purpose of this machine becomes incredibly clear.
Okay, let's start with photo. This comes from the Greek word phos, and it just means light. So boom, right away we've got our first huge clue. This thing works with light. And that leads us right to color. Seems pretty obvious, but think about it. It's totally connected to photo. Color is just how our brains interpret the light that bounces off stuff. So this machine is definitely going to analyze that whole interaction.
And last but not least, meter. This one's easy, right? It's just like a speedometer or a thermometer. A meter is anything that measures something and gives you a clear, simple number.
So let's put it all together. What do we get? A photocolorimeter is literally a light color measurer. That's its whole job. It uses light to measure exactly how intense a color is in some liquid. That's all there is to it. Simple as that.
Okay, so we've cracked the name. We know what it does. But the big question is, how does a machine actually see color and slap a number on it? Well, it's not magic. It's actually a really clever process.
It all really boils down to 3 basic steps. First, you gotta set a baseline. You shine a light through a totally clear liquid. They call it a blank. And you tell the machine, okay, this right here, this is 0. Next, you swap that out and put your colored liquid in. And then, for the final step, the machine just measures how much of that original light gets blocked or absorbed by the color.
And hey, look at the machine itself. See those knobs? The ones labeled Set Abs? That stands for Set Absorbance. And that's exactly how you do step 1. You use those to tell the machine that the clear liquid is your starting point, your absolute 0.
And this little spot right here? This is where the magic happens. That slot is the sample holder. You put a little vial of your colored liquid in there, close the lid to keep any of the light out, and let the machine do its thing.
Okay, so we've zeroed it out, we've put our sample in. Now what? What does the machine spit out at the end of all this? What's the final answer look like?
It's not going to give you like a beautiful description of the color. It's not going to show you a picture. It gives you something way simpler and way more powerful.
Just this, a number, in this case 0.48. All that technology, the light, the sensors, it all comes down to one single precise value.
And there it is, right on the machine's display. That is the answer it gives you. But what does it actually mean?
So that number, that 0.48, has a name. It's called absorbance. It's just a value that tells you exactly how much light the color blocked. Think of it like this. A really light pale blue liquid might barely register, maybe a 0.10. But a super dark, inky blue, that's going to have a much higher number because it's absorbing way more light.
All right, so turning a color into a number is cool, I guess. But why does it matter? I mean, why go through all this trouble? The answer is where this simple measurement becomes something huge.
Well, this is the whole game right here. Our eyes are amazing, but let's be honest, they're subjective. What I call sky blue, you might call light blue. But science and industry, they can't run on kinda blue. They need precision. This machine takes a fuzzy observation and turns it into concrete, repeatable data.
There's that famous quote from the management guru Peter Drucker. What gets measured gets managed. It's so true. If you can't measure something with real numbers, you can't really control it. And this little box is a master of measurement. And that is why this little box is so powerful. That one little number can tell a scientist the exact concentration of a chemical in a solution. It can let them watch a chemical reaction happen in real time. It can be used to spot tiny impurities in our drinking water or to make sure the color of your favorite soda is exactly the same every single time. It's all about consistency and knowledge.
So when you boil it all down, that's the beautiful, simple trick this machine pulls off. It takes a quality, the color blue, and turns it into a quantity,
the number 0.48. It turns what we see